Section 10.3, we're going to start talking about another line in a circle called a chord. Okay, but before that, what has always been the most important part of a circle? Center. Put it in. Put a center in. Give me a letter. O. Okay, so this is circle O. Remember, circles are named based off of their center. So this would be named circle O. Okay. What's another important piece of a circle? It is a radius. Don't draw it. Okay, what else? Diameter is important. Don't draw it. What else? Okay, what line did we talk about on Tuesday? A tangent line. Don't draw it. I'm going to draw it as a review, though. Tangent line. How do you know it's a tangent line? Touches one point, and it creates a 90-degree angle. Okay, that's how you know if that's a tangent line. So today we're going to be talking about a chord. Go ahead and draw this line for me. And then give it endpoints. Name them P and Q. Okay, that line right there is called a chord. Okay, that line is called a chord. Okay, I'm going to give you a definition. Okay, a chord is a line inside the circle whose endpoints are on the edge of the circle. And then along with that, a little note to write underneath it, does not go through the center. So a chord is a line inside the circle whose endpoints are on the edge of a circle. So that's our line PQ here. Endpoints are on the circle. It goes through the circle. That blue note that I have there, it says it does not go through the center. If it did go through the center, what is that? That's a diameter. Okay, so a chord does not go through the center. If it did, it would just be called the diameter. Okay. What do you think of when you hear the word chord? Spelled this way. What'd you say?
At least 3 musical notes played at the same time.
A musical note. Okay, it does have to do with music, though. What instrument has chords?
Yes. Guitars.
Guitars. That's what I was looking for. A guitar has chords, right? Are those chords pulled tight or are they let loose?
Tight.
They're pulled tight, right? If they weren't pulled tight, could you play the guitar? No. Okay, so a chord, what I want you to write in parentheses, just as a reminder, I want you to think of a guitar chord. The reason for that is we're going to learn another vocab term of a line next week, and I know you're going to get them confused. Okay, so for a chord, endpoints are on the circle, so you know that this line is pulled tight between those two endpoints. Okay, using that as just a little example to compare to. Go ahead and find this example in your notes, example 1. It wants to know why, go ahead and mark this too. It wants to know why these two angles are congruent to each other. Okay, we haven't seen that symbol in a while. What's that mean? Congruent, yep. It wants to know why those two angles are congruent to each other. It gave us that these two lines are congruent to each other. What are these two lines called? Chords, yep. Off to the side, right, CB and DE are chords. Okay, so it told us that the two chords are equal length. Talk to me. Why do you think those two angles are the same? Okay, you both said the same thing. They're connected to the endpoints. What you're saying is these angles are connected to the two endpoints. So why does that make them the same angle? Because the chords are the same length, right? Here, some of you might think, well, they're vertical angles. Are they? Why not? They're not straight lines, right? This is not a straight line, and this is not a straight line. So those are not considered vertical angles. So that's not the reason for that. Another way you might say is, well, their arc measures would be the same as their interior, right? We talked about that. So if the measure of this one was 45, what would its arc measure be? Also 45. Okay. Make an angle with your hands real quick. Okay. Pretend people watching the video are making this shape with their hands. Okay. Say hi to the State FFA people.
Spencer.
Okay. So making a V with your hands, pretend that between your fingertips here, there's a line connecting it to make a triangle. Yes? Okay, so we're talking about the angle being created by your wrists. What happens when you shorten that angle or you make it smaller? What happens to the side?
It's longer.
So where we started, the side's right here. What happens to the side when the angle gets smaller? It gets shorter, right? What happens when you make the angle bigger? It gets bigger. So if this angle gets bigger, this side is also going to get bigger also, okay? What we talked about before Christmas break, we said if this angle, remember the angle corresponds with their opposite sides. Okay, so if this side is the same as this side, that would have to mean that their two angles have to be the same. Okay, because their two side lengths are the same. So that would mean their interior angles would also have to be the same. Okay. So this one also works vice versa. I'm going to give you a little definition here. Right, if two chords are congruent, comma, then their corresponding angles are congruent. Now I want you to make another note saying that this also works vice versa. What do I mean by vice versa? Right, I just swapped this thing, or that statement. It says, if I said if the corresponding angles are congruent, then the two chords are going to be congruent. So that statement works both ways. Okay, so if you know one, you know the other. Okay, side question. What do I know about all of these lines right here? Why? They're a radius, right? So if I said this radius is 4, that would mean every other radius is also 4. Okay, and then also that brings back the side, right? Yep. Okay, questions on this one? I know we didn't do any math, but understanding how that works and how it's related to each other, yes? Okay, let's look at example 2. Right there. You have this example in your notes. Okay, what are these two lines right here? Chords, yep, make that note. NM and PQ are chords. Okay. Go ahead and make these markings. I'm going to tell you that these two chords are the same length. Okay. If those two chords are the same length, what do you think is going to be about the arcs? The arcs are also going to be the same. Yep. So if two chords are congruent, then their arc measures are congruent. And this also works vice versa. So if their arc measures are congruent, then the two chords are congruent. So in your picture, you can mark those as the same. Okay, and that is what I just put into words for you here. That's what your statement says underneath the picture. Okay. So in this example 3, I just heard what's that. It is a little complicated than the other ones. Okay, but let's break this down. What are the chords in this one? Yep, write that down. A, B, and C, D are chords. Okay. I'm going to ask you this. Are SE and SF radius?
Yeah. No.
Why not?
Because they're connected to the cord. Right?
They're not connected to the outside of the circle. They're connected to the cord. Okay. What this one says, and go ahead and mark it. It says if those two lines that create a 90-degree angle with the chord are equal, then the two chords are equal to each other. Think back. What does this line mean? What's that called? First of all, what does a right angle mean to a line? If two lines make a right angle, what are they? Perpendicular. Okay. And if I tell you it splits the chord in half. Perpendicular bisector. Write that down. Perpendicular bisector is SE. And I know I wrote that weird. And SF. Those two lines are perpendicular bisectors. Okay, they create a 90-degree angle with the chord, and they end up splitting that chord in half. So if I asked you this, if I tell you that this chord is 6, what would the length of AE be? 3. Yep, that's how it works. Yep. And then it has this one in words for you. I'm not going to change the wording to that, but also make the note works vice versa. So if the two chords were the same, then those two perpendicular bisectors would be the same. Right? Okay. So for practice on these, now we're going to put it with actual math problems. So I want you to do on the back 5 through 10. 5 through 10 is over the same diagram. Okay. In the diagram, it does have some things labeled for you. The other stuff that you need to know is in the directions. So take out the directions. So it tells you this and this. Take that and maybe mark it in your picture so you know. Okay, so for practice, go ahead and do examples 5 through 10, and then I'll come back and we'll do them together. So I'm going to go ahead and take the information from the directions and put it in the picture. What does that little symbol mean right there? Arc. So if I come up here, arc AB is 43. And then it tells us, I know it's kind of hard to put in the picture, but it does tell us that the two chords are equal to each other. Okay. So with that, it wants us to know what DF is. So DF, it wants to know the length of this chord. Ideas. Length of this chord.
4. Because you take the 2 from what? C, G,
So what a lot of you are seeing is that this length is 2, yes?
Yeah.
Okay. What do we know this side is? Why? It's that perpendicular bisector, right? Yep. So that side is 2, so this whole thing is 4. Well, in the directions it told us that AC and DF were the same, so then what's DF? 4. Yep. DF is 4. All right. Number 6, it wants to know AC, arc AC. So from here to here.
86.
Why? Yes, this is also 43. So if I add those together, I get 86. Good. FH, we've kind of already talked about it. What's the length of half of DF? 2. Yep. Arc DE, that's this arc right here. Why is that one also 43? Yep, it's congruent. If this chord and this chord are the same, what do we know about their arcs? They're also the same. Yep. AC. Right here. Yep, we already talked about that. That one's 4. And then DF. We also talked about that one a little bit. That one's also 86. So see how a lot of it was just not, I won't want to say assuming, because you never want to assume, but see how they all kind of connect to one another and everything that's connecting to each other? Okay. All right. If you stuck this long, guess what? I get to tell you how to do one of the questions on your homework. See what happens when you watch the video? You get answers sometimes. Okay. On your homework, it might ask you to find, for example, if it asks you find the length of CP. Is there a CP in the picture? No. Can I make a CP? Yes. I'm just going to connect C and P together. Okay. And then let's just pretend I told you this was 5. Okay. How would you find the length of CP? I heard someone say it. What did you guys say it was, Ashton? It's a triangle. Specifically, what kind of triangle? It's a right triangle. How do you find a missing side of a right triangle? Pythagorean theorem. Okay, so let's just run through this real quick. Remember, C is important. What has to be plugged in for C every time? Across from the right angle. What is it? In our case, it's x, right? So we have x squared equals 5 squared plus 2 squared. What's 5 squared? 25 plus 4 equals, that does equal 29. 29 equals x squared. What would my last step be? Square root. I know it doesn't work out nice. It should on your homework, I hope. Okay. So, and also, if it asks for FP,
Same, right?
Take it.
why?
Because they're
Perpendicular bisect.
Radius. They're both radius, right? Yes? What about DP?
Both have a diameter.
Radius, the same. We all, for some reason, forget about the radius. I feel like that's the most general part of the circle. Always remember that that's there. Okay? Always remember that you have the radius and you should always be able to know what it is. Okay? If it's given to you in the first place. Okay?